Welcome everyone, and thank you for joining us today. In this presentation, we will be discussing our study on the impact of climate change on temperature and precipitation patterns across Pakistan's agroecological zones. We will explore the historical trends, current data, and future projections, and the effects of these changes. This project is a collaborative effort by Hania Jahangir and Iraj Jamil, who have worked together to gather and analyze data, perform statistical assessments, and develop strategies for climate adaptation and resilience. We are excited to share our findings and discuss potential solutions to address the challenges posed by climate change in Pakistan. Climate change is reshaping our planet, altering temperature and precipitation patterns globally. This study dives into these shifts with a specific focus on Pakistan's agroecological zones. By analyzing data from 2010 to 2100, it highlights how rising temperatures and changing rainfall distributions are impacting the region. The research also underscores the increasing frequency of extreme weather events, posing significant challenges for regional climate resilience and other key impacts on our environment. Understanding these variations is crucial for developing strategies to address future climate challenges and safeguard vulnerable ecosystems and communities. Global climate change is driven by greenhouse gas emissions from fossil fuels, industry, and agriculture. Carbon dioxide, the leading contributor, reached a record 37.4 billion tons in 2023. Methane, a more potent gas, is mainly released through agriculture and fossil fuels production. Deforestation, which reduced global tree cover by 4.2% from 1990 to 2020, worsens the situation. The energy sector accounts for 73% of global emissions, while agriculture adds 14%. Without action, the global temperature could rise by 2.6 degrees Celsius to 4.8 degrees Celsius by 2100, exceeding the Paris Agreement target. Immediate action. Global temperatures have risen by 1.2 degrees Celsius since the 1970s, with warming accelerating rapidly. The Arctic is heating twice as fast as the rest of the planet, and land areas are warming faster than oceans. 2023, the warmest year on record, underscores the urgency of addressing climate change. These global trends are intensifying risks in vulnerable regions like Pakistan, where shifting weather patterns threaten agriculture, water resources, and ecosystems. Immediate action is critical to mitigate these impacts and build climate resilience. This study starts with a global literature review exploring changes in seasonal temperature and rainfall patterns worldwide. It then focuses on Pakistan's agroecological zones, analyzing shifts in temperature and rainfall unique to each region's climatic needs. By narrowing proper spatial alignment, we then convert temperature and precipitation data into geodata frames and perform a spatial join with ecological zones. Next, we calculate zonal statistics by grouping data by zone and year, calculating monthly averages, and visualizing both spatial and temporal trends. To further explore climate relationships, we conduct trend and correlation analysis using scatter plots and calculate correlation coefficients. Finally, statistical analysis of yearly averages help assess the connections between temperature and precipitation, providing valuable insights for agricultural planning and climate adaptation strategies. This study involves several key steps in data analysis. First, we pre-process and align climate data with Pakistan's agroecological zones, ensuring proper spatial alignment. We then convert temperature and precipitation data into geodata frames and perform a spatial join with ecological zones. Next, we calculate zonal statistics by grouping data by zone and year, calculating monthly averages, and visualizing both spatial and temporal trends. To further explore climate relationships, we conduct trend and correlation analysis using scatter plots and calculate correlation coefficients. Finally, statistical analysis of yearly averages help assess the connections between temperature and precipitation, providing valuable insights for agricultural planning and climate adaptation strategies. From 2010 to 2024, the yearly average temperature in Pakistan increased by 3.6 degrees Celsius, rising from 19.7 degrees Celsius to 23.3 degrees Celsius. While fluctuations occurred, including a dip in 2017, the general trend shows a consistent warming. The most significant rise took place from 2021 to 2024, with a 1.36 degrees Celsius increase. Looking ahead, moderate warming is expected from 2025 to 2035, followed by rapid warming after 2050, with temperatures rising by 1.06 degrees Celsius every 5 years. From 2010 to 2024, Pakistan saw significant fluctuations in average precipitation, peaking at 3.69 mm in 2010 before dropping to 0.56 mm in 2018. Despite short-term recoveries, the overall trend is downwards, threatening water resources, agriculture, and ecosystems. Looking ahead, precipitation is expected to decrease from 2025 to 2035, stabilize from 2060 to 2075, and become more variable from 2080 to 2095, increasing the risk of droughts and floods. This highlights the urgent need for adaptive strategies in water management and agriculture. The choropleth maps of temperature and rainfall based on agroecological zones defined by PARC highlight how climate varies across the country. Eastern zones receive heavy rainfall during the monsoon, while western zones get most rain in winter due to westerly disturbances. Analysis of temperature and rainfall shows a weak or inconsistent relationship, with temperature having minimal impact on rainfall. Factors like elevation, topography, and seasonal weather systems play a more significant role in shaping regional and climate patterns. Over the past 15 years, Pakistan has experienced significant temperature increase and erratic precipitation patterns. Temperature is projected to rise by 3.6 degrees Celsius by 2095. With accelerated warming expected in the coming decades, precipitation is becoming increasingly erratic with fluctuating periods of drought and rainfall. These climate shifts pose major challenges to water resources, agriculture, and ecosystems. To adapt, we need drought resistant crops, improved water conservation, and strategies to withstand climate extremes. Mitigation and adaptation efforts are crucial to minimize impacts and ensure long term agriculture sustainability.